Hello everyone. Second time around for me. Didn't have the mic open the first time. At least I'm a little bit more prepared now. Okay, so here's just a starter. We have this guy, Jim Fan, who has
paper, and let me show that to you.
Yeah.
So this is the
This
Voyager
mapping program.
research project that he's referencing. And here's his name right there. And in fact,
You can
I
find
made a
the
video about
you can find the research project inside the link to the description.
this research paper because it was so incredible. And what Voyager was the first time where we actually saw AI agents using tools. And not only using tools, but creating and saving their own tools. And now all of the modern AI agent projects can do exactly this. But this is the first time I've seen it. And let's take a look at that accomplishment quickly in one graph. So what you're seeing here is the Minecraft tech tree. So basically, the more you play Minecraft,
Okay, yeah. We got that part, but the cool part ends up being
look at this library for future.
Perspective. Always able to get a program.
you can
What he
I apologize. Okay. So there's this thing, Project Metamorph. I think my brain immediately starts going to aliens, xenomorphs. So if you go to his webpage that he has up and sharing for everybody, you can see the Project Voyager here. It's in my description, and you can see the Metamorph program here, right? So then you have Eureka, which then writes functions for many of these objects, which is similar to using many Voyagers together, doing something like the Metamorph thing and the Voyager thing simultaneously. So see? Coolness. Very cool. That allowed for the bot that in real life that we've seen already, which is I think in the thumbnail for this. See the thumbnail down there? There you go, that robot that can drive around and do stuff. I was looking previously for it in the video, but I can't actually seem to find it here. But real life applications with this kind of technology are not only coming, they're available right now. And that's daunting, but also amazing. Look at this.
So it's very much like the virtual sparring dojo in the movie Matrix. And this car racing scene is where simulation has crossed the uncanny valley. Thanks to hardware-accelerated ray tracing, we're able to render extremely complex scenes with breathtaking levels of details. And this photorealism you see here will help us train computer vision models that will become the eyes of every AI agent. And what's more, Isaac Sim can procedurally generate worlds with infinite variations so that no two look the same.
Wow, did he just drop so much cool stuff. So what he is saying Isaac Sim is, not only can it operate within any embodiment, but it actually has the ability to generate worlds that are photorealistic in unlimited variation and train the agents within those worlds. So if you have a virtual world that is nearly a pixel perfect representation of the real world that a robot is trained on, when we actually transfer that knowledge into a real world robot, it already knows how to operate within that real world because of that training.
So here's an interesting idea. If an agent is able to master 10,000 simulations, then it may very well just generalize to a real physical world, which is simply the 10,001st reality.
All right, now he's getting into simulation theory, and I tend to believe in it. And for those of you who are not aware, simulation theory is that we are living in a simulation ourselves. It kind of makes sense. Looking at the progress of computing over the last 50 years and what we're able to simulate within computer environments today is pretty stunning. Now, if it continues to improve at the rate that it has been, at a certain point, the simulation is going to become so real, we are not going to be able to tell the difference between the simulation and the real world. And at that point,
Just because you can't tell the difference between the simulation and the real world doesn't mean that this isn't a simulation. Just
real world is just a simulation. And this is what Elon Musk and many other thought leaders believe as well.
And let that sink in. As we progress through this map, we will eventually get to the upper right corner, which is a single agent that generalizes across all three axes.
So this is the Metamorph project. He also has this here for us to try. I tried to set it up today. I spent a couple hours. There's an actual Docker file on it, but I feel as though I'm being stalled due to Microsoft issues. It doesn't really seem to work on WSL for me very well. If I actually click on it, go to the code, there are issues, and it seems to be similar to the issues that I have. I did end up getting a little bit further than this guy, but and that's how you answer it, or that's how I got past it, but I couldn't get the simulation to show up for me. I wish there was more training or in-depth tutorials on some of the stuff, but you know, the guy's busy.
Instructs a white box learnable neural network. And here, a prompt, and have CGI generated that is exactly what you're describing without the need for visual.
We are able to scale up Eureka thanks to Isaac Jim. Okay, it's not Isaac Sim, it's Isaac Jim. Control F, ISAACGYM. Not it. Okay. Can I get Isaac Jim somewhere? So I put the link to his page in the description as well. ISAACGYM. Isaac Jim, an Nvidia tool. Amazing. Look at that, that's cool. Wow. Imagine all of them with some of them falling over, some of them just walking sideways, but they're all learning together on this terrain, and you take the best one out of the whole lot. Oh my god, I want to play with that so much. End-to-end GPU accelerated. Support for importing URDF and MJCF files and automatic convex decomposition. Isaac Sim. Wait, it is Isaac Sim. And Isaac Jim. Get technical training, developer insights, and access to experts at GTC. Get early bird pricing now. How about I just join? This is for me. Ugh. Log on options. Okay, so I have to lock in options, but I have to move you guys down. Sorry, guys. And I just launch your authentication app. Oh, it's on my phone. Sorry. Okay, welcome back. While I yeah, I'm gonna turn that off and turn back on that other video. Isaac Jim. Oh, it was on the other page. So authenticator app. Nvidia. Oh yeah. Be cool to do something with this, wouldn't it? Oh, I didn't describe. I got a trench coat from my wife. I pretended to be a murderer. But yeah, this is really just cool. Oh, I want to see this one. Oh, this is the robot on Mars. Learning to get to different locations. Oh, wow. Look at that. Balancing a ball on a plate. Different momentums. Oh, that's so cool. Learning how to pick up a ball, a cube. like this one. This is oh, sorry. Learning how to walk. Just sped up to a few 100,000 individuals, and it's just so cool. Anyhow, Isaac Jim fan, Isaac Sim, and I've added in MJ text to the description of this video because I had a problem trying to find it for myself when I was starting off trying to use the Metamorph program that he has here, and just to make it a bit easier for anybody that gives a damn, if you go into code, you're going to be asked at some point for the MJ text, and you need to put it into the Docker. Doesn't even mention it here. It is MJ text, isn't it? Yeah. So yes, you need to put it into the Docker area. MJ key text. Text MJ key. Yeah. So you're gonna have to put it in there, and then you'd be running this for the training stuff, and then running that to get the GPU compute. And for some reason, it just doesn't run for me, and I only looked at it for one day. But the Docker file is here. Should just be able to run. I had Docker desktop up and running. I just deleted off everything, and I was working on another facial recognition thing from Matthew Berman's channel. I had great plans for cool projects today and demos to blow up the channel, but as per usual, it's mostly about failing in order to succeed, and if there's anybody that knows how to fail, it's me. So yeah, just don't get down about it, guys. Just get up and start doing it again. And so therefore tomorrow, after I do a few cool things or important things, I'm going to be coming back to doing the facial recognition again, and then also trying to get the Metamorph project. So if I end up getting up and running, believe me, I'll be here talking about it, and maybe one day I'll get around to being able to work with this. But let's watch something depressing. Tech layoffs.
We are doing a very impromptu video. This actually was not the video I was going to be posting when you watch this. And the reason for that is I just had this feeling in me that we really need to talk about tech layoffs. I mean, everywhere you look, everywhere you speak to someone even, you are probably going to hear about tech layoff. And I don't know about you, but for me, as someone who works in tech, the last few weeks, especially this past week, I would say, has made me feel a little bit, I don't even know what the words are, a little bit strange, a little bit uncomfortable, if you will. And I thought, you know what? It's time we talk about it. Now, I'm not going to lie, I went into 2024 kind of naive, if I'm being totally honest with you, looking back. I thought, you know what, 2023 was a really brutal year for tech, especially with so many layoffs. We're going into 2024, experts are saying, I think holding a coffee cup and everything's burning around him. It's a classic, by the way. But really, is AI taking over jobs? Well, here's what 365 data science.
Yeah, will replace us. No programmers. Yeah, ChatGPT will replace us finally.
Tried to figure out and use once again the data to see if this actually is happening. By the way, I'm using this report because I just find it very interesting from an actual data standpoint. I don't know about you, but I'm sure many of us in the TIFF in Tech community, good thing I can talk, this is what happens when you're filming at 7 p.m. at night. In the TIFF in Tech community, you're very numbers or data driven in different capacities, and for me, understanding the data behind it versus just articles where they were assuming things or making assumptions. Anyways, that's a long story short as to why I'm using the 365 data science report. So going down into it, I found it really interesting though, what types of roles were laid off? And I mean, there was really every type of role. No role has been safe, including software developers. But what they report is that 28% of all layoffs were within HR. And I find this really interesting for a few reasons. I mean, when you think of HR as a whole, it is one area where well, let's not say a lot, but some functions are being placed by automation. A lot of these tools that are coming out around AI that companies are adapting to or starting to integrate really do have a direct impact on HR. We just don't see it as much as individuals who aren't in HR, if you're someone watching this that isn't in HR, and we don't really understand that there are a lot of systems being put in place that can kind of do that manual tasks that were covered by HR. So that is my theory or reasoning as to what is going on with big tech laying off so many individuals. And I needed to have this really logical explanation for it because I Some days can feel very overwhelming when you're talking to a friend and you hear they know someone who got laid off, or you see in the news every day it feels like different companies laying off employees. It just makes you feel very uneasy. I thought I'd share with you as well some signs as to
There is a new Mamba model, which is what we're going to discuss in this video. If you're completely new here, Mamba is an alternative architecture, a state space model architecture, which is alternative to transformers. Transformers is one of the most popular deep learning architecture loaded with Mamba LM head model, which comes from Mamba SSM. Then this model, actually the fine-tuned data, it follows the chat template of Zephyr 7 billion beta. So the chat template ID comes from there. So this line says if you have GPU CUDA, then you can enable CUDA. If not, you go with CPU, and this is the exact model in itself. Now is the time where we are going to set the EOS token. So this is basically to tell the chat template or the model the instructions when the particular sentence actually ends from the model response in itself. You set the EOS token, you get the tokenizer, and then you get the chat template, and then you load the model from Mamba LM head model dot from pre-train. The model name, which is directly copied from here, this is the model name from Hugging Face's model hub. Device, in this case CUDA, but if you have CPU, I'm not sure how it works. And then the data type. Once this is done, run it. It should be, at this point you should have downloaded the model. This step might take a little bit of time, but at this point you should have downloaded the model, you should have set the tokenizer, you are completely ready to go. The next thing is, instead of making this a simple one question and answer, this code actually lets you have a chat. I'll tell you how that happens. That primarily happens thankingly for the list. So this creates a Python list called messages, and that messages basically appends all the conversations. So if you go here, first is the user question. What is the user question? Tell me 5 places to visit in Bangalore. So the assistant answers. Then the user just simply says maybe in Chennai. But the assistant still understands that, in this case the Mamba model still understands that I'm talking about 5 places to visit in Chennai, not just simply anything about Chennai. So it still gives me an answer. This is primarily a list. You can see it is all part of a list, or a kind of like a JSON structure, not necessarily. So it's a list, and inside that you're going to send a prompt with the role user. So you're converting that this into a dictionary, so which is like role plus prompt. The prompt is where you ask the question, and that goes get appended into the messages. And at this point the messages would be empty. It's an empty list, you append it. Then you take that and apply the chat template and send it through the tokenizer and send it to the GPU device, and then you use model.generate to ultimately generate the output. So here we are using a max length of 2000 tokens. You can play with that. I didn't find on the model card what is the context window of this particular model, but I assume it might be 2048, so we are sticking to 2000. So typically transformer models, when you say 2000, it would take a lot of time, but when you have more conversations, you will start hitting out of memory error. But in this case, actually you can see it's quite flat for me. I still do not do like an equal apple to apple comparison between Mamba and a transformer based model with similar size on Google Colab to see what is the difference, but at least like I can feel that maybe it is not hitting out of memory OOM error. The next thing is, once we get the output, then we have to decode it. Once we decode it and get the message separately, we can append the message back to the dictionary in itself, the messages dictionary, the messages list, so that the messages are there, like the assistant message is there with the role assistant, and print the message. Was the question I asked? Tell me 5 sites to visit in Bangalore. Give me Mysore Palace, St. Mary's Church, Kaban Park, Vidhana Sauda, Lal Bagh Fort. Good places, anybody would recommend. Then to keep the conversation going on, instead of the messages, means I didn't want to again make it empty, I went ahead and then said, okay, maybe in Chennai, and the rest of the things remain the same. So it gives me Marina Beach, Fort St. George, Anna Square, Chinna Thambi Reddige Temple, and Chennai Central Railway Station. Good, well and good. So I'm going to quickly show you how I'm going to do it. And if you see, this is how the messages list look like. We asked a question, the assistant responds, and we asked another question, which is user and the assistant response. So user, assistant, user, assistant. Let me go ahead, copy the last line. Once you have pasted it, you can say anything. So you can keep the conversation going on. So for example, how about, let me just say France, maybe not France, Germany. And and ideally it is supposed to give me 5 places in Germany to visit. That's the whole idea. Then it keeps the conversation going. And whenever you want to reset the conversation, all you have to do is reset the list. If you make the messages list empty, you should be technically, yeah, it sticks to it. So it gives me Berlin Wall Memorial, Brandenburg Gate, Pergamon Museum, Berlin Wall Memorial. Once again, it repeated. Okay. Anyways, I didn't have enough information about Berlin maybe. So the next thing that I wanted to try is very simply, I'm going to go here and then say, tell me 5 places to visit with itinerary, or with let's say itinerary, maybe not itinerary. Tell me 5 places to visit in Bangalore in one day and give me the response in JSON. So the reason why I'm asking this question is because I've known that OpenHermes model itself is really good in giving JSON responses. So I wanted to see, because this is OpenHermes dataset, and whether the Mamba can at least try to do that. And again, this requires extensive testing. This is not a model testing or quality of the model video in itself. I just wanted to say that people have started fine-tuning Mamba models, and it is quite exciting. But because I've taken this liberty to test this model, why not ask this model to give the response?
My understanding of Mamba is that it doesn't lose its context so soon. So I'm just going to verify again. I should have watched the video.
If you're completely new here, Mamba is an alternative architecture, a state space model architecture, which is alternative to transformers. Transformers is one of the most popular deep learning architectures today, and all the large language models, or at least most of the large language models that you see, are built on top of transformers. The problem with transformers, when you increase the context length, it doesn't require computer memory linearly. In fact, it requires quadratically. So that creates a problem in scaling of transformers, and that is why people started looking for alternatives, and that is where Mamba is very interesting. We have seen a lot of Mamba related content in this video on this channel, and the latest one is a very new model, and this actually indicates that Mamba has a really great future. So I'm going to show you in this video how to use the latest Mamba 2.8 billion instruct OpenHermes model and on Google Colab. So you can run this model yourself on Google Colab. I've already prepared
So let's see, Mamba dash 2.8 B dash instruct dash open armies. Right? This one or this one? Both look the same. That's what he has.
the Google Colab. I'll share it with you. But before that, let's quickly look at the model in itself. This model is from Clebrain, but it is created by a favorite model creator of mine, Manuel Romeo. So this model is there, which is Mamba 2.8 billion parameter model, instruct fine-tuned on the OpenHermes dataset. Now, OpenHermes dataset is a very popular dataset, to be honest. It's completely permissive, and that is powering the OpenHermes model. So we all know how good OpenHermes model is. So the model itself should be good depending upon the dataset that we have got. So what is the combination of OpenHermes dataset? OpenHermes dataset has got 242,000 entries, primarily GPT-4 generated. It's a combination of the following: GP Teacher, which has got role-playing and code instruct dataset. This is by Technium. Wizard LM, you might expect a lot of math. Aeroboros, Camel AI's domain experts, Code Alpaca by Help, and GPT-4 LM and unnatural instructions. This is by filtering some existing dataset. So this is all part of the 242,000 entries that basically went inside OpenHermes dataset. Now this is what has been used to fine-tune the Mamba 2.8 billion dataset, and that has given us this particular model. We don't have a lot of information on the model called in itself. It has got a strange license, WTFPL. I tried to find out what this meant. I didn't know. I don't know if it is somebody trying to troll us or not. But anyways, that's the license we have got. So now, how do we run this on Google Colab? Thanks to Manuel Romeo, who has also shared the code with us, which works very perfectly, except one issue that I've managed to fix it. So first you need Torch, PyTorch, then you need Transformers, then you need Causal,
wonderful footer. He's great to watch. Anyway, it's getting late again tonight for me, guys, so I'm going to head off to bed, and I hope that some of what I've done here today has been interesting and useful.